We're going to go over an example from last week on finding z-scores. We have an example that says the average temperature for February was 23 degrees with a standard deviation of 4.2. What is the z-score for 17? We're going to plug into our z-score formula, and we're going to get z is equal to 17 minus 23 over 4.2. Simplify that, and we get a big long decimal, negative 1.42857143, and that rounds to negative 1.43. Our new lesson is going to be finding permutations and combinations and calculating permutations and combinations. All right, in permutations and combinations, we're going to be using a notation that is called factorial notation. This is shown as n, and it looks like an exclamation mark afterwards. That is n factorial, and that means that we're going to multiply all the numbers in descending order from n to 1. So if I was to find the value of 5 factorial, that means that I'm going to be multiplying 5 times 4 times 3 times 2 times 1 and simplifying to equal 120. A permutation is an arrangement of objects that are in a specific order. Order matters in a permutation. The notation can be shown as capital letter P and in parentheses n comma r, where n represents the total number of objects and r represents the number of ways. Another way of showing it is capital P, and we have subscripts of n and r, and we can also find using the formula n factorial over n minus r factorial. A combination's arrangement of objects in which order does not matter. It can be shown as capital C and in parentheses n comma r, where n again is the number of objects and r is the number of ways. It can also be shown as capital C with subscripts of n and r, or it could be shown in parentheses n over r. The formula for a combination is n factorial over r factorial times n minus r factorial. All right, we're going to look at 3 examples. The first one is 8 factorial over 5 factorial. We know that 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial in the denominator is 5 times 4 times 3 times 2 times 1. So what we're doing is canceling the 5 factorial, and we end up with 8 times 7 times 6, which is 336. The second example is a permutation. N has a value of 6. R has a value of 3. We're going to plug into the formula n factorial over n minus r factorial, which is going to give us 6 factorial over 3 factorial. We're going to expand this 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. The 3 factorials cancel out, and we're going to get 6 times 5 times 4, which is 120. Last example is an example of evaluating a combination. N has a value of 5, and R has a value of 3. We are plugging into the formula n factorial over r factorial times n minus r factorial. That is 5 factorial over 3 factorial times 5 minus 3 factorial, and that ends up being 5 factorial over 3 factorial times 2 factorial. We expand. The numerator is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1 times 2 factorial, which is 2 times 1. The 3 factorials cancel out, and it gives us 5 times 4 over 2 times 1, which is going to be equal to 10. All right, permutation order matters. Combination order does not matter. An example of permutation might be phone numbers. In a phone number, order matters. We could have races where you're finishing first, second, third place. electing specific officers for president, vice president, secretary, treasurer. You may have combinations, like locker combinations, which would be in a specific order. These are all examples of permutations. A combination order does not matter. You're just picking a certain number, choosing a certain number, and it doesn't matter how we choose it. So in a permutation, order matters. In a combination, order does not matter. All right, the example on the do now is 5 factorial. That is 5 times 4 times 3 times 2 times 1. Multiply, and I did 5 times 4, 3 times 2 times 1, which would be 120. We could just type the whole expression into Desmos to simplify. All right, we have 4 factorial times 3 factorial. This is going to be 4 times 3 times 2 times 1 times 3 times 2 times 1. Multiply, I did 4 times 3, 2 times 1, and 3 times 2 times 1, and I got 24 times 6, which is 144. All right, we are finding the value of the permutation where n is equal to 8 and r is equal to 5. And what I did is I plugged into my formula n factorial over n minus r factorial, and it ended up being 8 factorial over 3 factorial. So I expand 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. The 3 times 2 times 1's cancel. It gives me 8 times 7 times 6 times 5 times 4, which is 6,720. As you notice, I do have the Desmos calculator pulled up, and that is because we are going to be actually using the calculator to find this permutation. So I'm going to click on functions. I'm going to scroll all the way to the bottom, and the last two things that you see are NPR and NCR. We are doing a permutation, therefore I'm going to choose NPR. To calculate this, I put in parentheses the two numbers. N is 8, N is always going to go first, and R is 5, and immediately I get an answer of 6,720. Can I use Desmos to find these values? Absolutely. The formulas are going to be on the formula sheet for those who have to take the SOL test, but we do not have to use the formula. We can just type it into Desmos. All right, same thing on this one. We're finding the combination where n is 10 and r is 7. I've gone ahead and plugged into the formula n factorial over r factorial times n minus r factorial. It ends up being 10 factorial over 7 factorial times 3 factorial. I write it in expanded notation, and what happens is the 7 factorials cancel out. It leaves 10 times 9 times 8 on top and 3 times 2 times 1 on the bottom. Simplify that, I get 720 divided by 6, and that is equal to 120. But I can use Desmos to do this problem. And I'm going to click on Functions. And when I do that, I'm going to go to the NCR. I'm going to type in the two numbers. We have 10, 7, and it automatically is 120. All right, this is just asking, does the following represent a permutation or a combination? How many ways are there to choose a committee of 3 people from a group of 5 people? I'm going to do a committee of 3. They do not have a specific office or a specific job to do. I just want 3 people. Therefore, in this order does not matter that I pick. And since order does not matter, we know it is a combination. Another example, same type of problem, is this a permutation or combination? How many ways are there to choose president, vice president, and secretary from a group of 5 people? We are choosing people for specific offices. A person to be vice president, a person to be secretary, a person to be president. Therefore, in this particular problem, order matters, and it would be a permutation. If we were evaluating this permutation, it would be capital P, and we would have N is a total of 5 people, and we are picking 3 officers. Therefore, it would be 5 permutation 3. All right, the last one, a basketball team has 11 players. How many ways can the coach choose 5 starting players? This is a combination. We're just going to pick 5 starting players. We're not picking a person for center, for guard, for forwards. We're just picking 5 players, 5 starters. So the order does not matter. We're going to go to Desmos, and we're going to type into Desmos. Go to Functions all the way to the bottom and choose NCR. We have 11 players, comma, 5, and we find that there are 462 ways that this coach can choose 5 starters. Notice in the upper right-hand corner, we have a picture of someone swimming. Swimming may have something to do with your attendance quiz for today.